Cursor sharing is an interesting one because cursor sharing applies to bind variables. So what I could do is I could use a big table and select a single row. My cursor sharing parameter is currently set to force, which means it will force any literal strings to be converted into bind variables. For a large database and reading, in this case, a single row from one table, it's actually more efficient to use exact. So the only way I could actually display this and using a bind variable would be in a stored procedure, but since I can't pull the explain plan from inside the stored procedure, there's actually no point in demonstrating it. The only point I'm making is that cursor sharing exact will actually override the replacement of a variable with a bind variable, or this value here with this bind variable or something like it, due to the application of the parameter cursor sharing equals force, and will simply allow access to this variable itself, so it's more likely to be faster. Generally, setting this hint is a little bit dubious and really only applies in data warehouses with very large tables. Let's take a quick look at dynamic sampling. First of all, I'm now going to use explain plan, so I'm going to set trace off. Then back to my script, I'm going to analyze statistics for the two tables I'm going to use in a query. In order to use dynamic sampling, I need at least two tables in the query. So let's go and analyze statistics on these two tables. And they're small, so it's fairly quick. I could also, well, I should compute statistics for indexes as well, but at this point I won't bother. What I'm going to do first of all is I'm going to run an explain plan for the join using the cost-based optimization with no hints, and it gives me these costs and these rows. Going back to here, I'm going to use an explain plan with dynamic sampling level 1 on the category table and dynamic sampling level 10 on the category table. So let's paste these in, and I've got cost 2 with these rows, and as you can see there's absolutely no difference whatsoever. The tables are very small, so what I should do is go to my simulation database and use some much larger tables, and in this case I should see a difference. And I'm going to run this again because I should have actually set auto trace off here because I'm actually getting an execution plan for the plan table query, which doesn't really help me. So let's run it again. Note that the last query took a long time to run because dynamic sampling set to 10 is forcing the entire general ledger table to be read. In other words, all its blocks. Now in this case, I have a cost of 3119 or 3120 for all of them, but note the number of rows read is different. In this case, I'm effectively doing the full table scan in the dynamic sampling process. The point is, I'm reading a lot fewer rows down here because it knows it only has to read a single row from the general ledger table, namely this guy COA equals 50028. There's only one instance of this row on the general ledger table. The point is the cost is the same because ultimately you still have to use full table access on the general ledger table. The obvious answer to this would be to tune the query and to force an index access into the general ledger table and then join to the COA table. I could even run timing tests with timing on and run the different versions of this query with dynamic sampling 1, 10 or off and see if there's actually a difference in execution speed. As you can see, the first one is 403, second one 401, third one 401. That's a little bit misleading because the first query has actually loaded all the data into the database buffer cache. So what I should do is actually run it again, based on the fact that any queries are reading from the buffer cache. And as you can see, we get a very slight difference with dynamic sampling. So it could be said that using dynamic sampling may be a little bit faster than using up-to-date statistics, although I wouldn't write home about that one. That's the hints that influence the optimizer.